Hello class, welcome to Stat 1200. I am your instructor, William Buellman, and today we are covering section 8.1, Basic Principles of Hypothesis Testing. Our objectives for today are to define the null and alternative hypothesis, state conclusions to hypothesis test, and distinguish between type 1 and type 2 errors. A study published in the Journal of the Air and Waste Management Association reported that the mean number of particulate matter, PM, produced by cars and light trucks in an urban area setting is 35 milligrams of PM per mile of travel. Suppose that a new engine design is proposed that is intended to reduce the amount of PM in the air. There are two possible outcomes that could happen with the new engine design. Either the new engine design will reduce the level of PM or it will not. These possibilities are called hypotheses. One of the hypotheses is called the null hypothesis. And the other is called the alternative hypothesis. The null hypothesis states that a parameter is equal to the specified value mu naught. The null hypothesis is denoted by h sub 0, or we call it h naught. The alternative hypothesis is denoted h1, or in other books you may see ha. There are three possible alternative hypotheses. Left-tailed states that the parameter is less than the value specified by the null hypothesis. For example, h1 mu is less than mu naught. Right-tailed states that the parameter is greater than the value specified by the null hypothesis. For example, h1 mu is greater than mu naught. Two-tailed states that the parameter is not equal to the value specified by the null hypothesis. For example, h1 such that mu is not equal to mu naught. Left-tailed and right-tailed hypotheses are also called one-tailed test. Example 1. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the appropriate null and alternative hypothesis. So we have to remember that the null hypothesis is that there is no difference. So we're going to say that mu is equal to 20 because that is the claim. The instructor thinks that the mean weight may be less than 20. So that's going to be our alternative, is that mu is less than 20. This is an example of a left-tailed test. Example 2. Last year, the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. State the appropriate null and alternative hypothesis. So again, the null hypothesis is assuming no change. So we're going to say mu is equal to 800. The real estate agent wanted to know if the rents had increased, so increase means greater than, so our alternative hypothesis is that mu is greater than 800. This is an example of a right-tailed test. Example 3. Scores on a standardized test have a mean of 70. Some modifications are made to the test, and the educator believes that the mean may have changed. State the appropriate null and alternative hypothesis. The null hypothesis is always that we assume things have not changed, so mu is equal to 70. And in this example, it didn't tell us whether the educator thought it increased or decreased. It just said the educator wanted to know if it changed. Therefore, our alternative is not equal to 70. This is an example of a two-tailed test. The purpose of a hypothesis test and to determine how likely it is that the null hypothesis is true. The idea behind a hypothesis test is similar to a criminal trial. At the beginning of the trial, the defendant is assumed to be innocent. Then the evidence is presented. If the evidence strongly indicates that the defendant is guilty, we abandon the assumption of innocence and conclude the defendant is guilty. In a hypothesis test, the null hypothesis is the defendant in the criminal trial. At the start of a hypothesis test, we assume that the null hypothesis is true. Then we look at the evidence which comes from data that have been collected. If the data strongly indicates the null hypothesis is false, we abandon our assumption that it is true and believe that the alternative hypothesis is correct. This is referred to as rejecting the null hypothesis. So here's a little diagram. Assume the null hypothesis is true, look at the evidence, decide whether or not to reject the null hypothesis. We may either reject the null hypothesis or fail to reject the null hypothesis. If the null hypothesis is rejected, the conclusion is straightforward. We conclude that the alternative, H1, is true. If the null hypothesis is not rejected, we are saying that there is not enough evidence to conclude that the alternative hypothesis is true. We are not saying that the null hypothesis is true. What we are saying is the null hypothesis might be true. Example 4. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs a test of the null hypothesis, mu equals 20, versus the alternative hypothesis, mu is less than 20. He rejects the null hypothesis. State an appropriate conclusion. Since H0 was rejected, we conclude that H1 is true. Thus, the mean weight of the cereal is less than 20 ounces. Example 5. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs a hypothesis test that H0 mu is equal to 20 versus H1 mu is less than 20. He does not reject the null hypothesis. State an appropriate conclusion. Since the null hypothesis was not rejected, there is not enough evidence to say that the alternative is true. Thus, we say there is not enough evidence to show that the mean weight of the cereal boxes is less than 20 ounces. When a hypothesis test is conducted and a decision is made, there is a possibility that it is the wrong decision. There are two ways in which a wrong decision may occur with hypothesis testing. If the null hypothesis is true, we might mistakenly reject it. A type 1 error occurs when we reject the null hypothesis and it's actually true. If the null hypothesis is false, we might mistakenly decide not to reject it. A type 2 error occurs when we do not reject the null hypothesis when it is actually false. So here's a little diagram that shows if the alternative hypothesis is true and we reject it, that's a type 1 error. If it's true and we fail to reject it, we've made the correct decision. If the null hypothesis is false and we reject it, we've made a correct decision. If the null hypothesis is false and we fail to reject it, we have a type 2 error. Example 6. The dean of a business school wants to determine whether the mean starting salary of graduates in her school is greater than $50,000. She will perform a hypothesis test with the following null and alternative hypothesis. So the null is that it does equal 50,000. The alternative is going to be that it's greater than 50,000. Suppose that the true mean is 50,000 and the dean rejects the null hypothesis. Is this a type 1 error, type 2 error, or a correct decision? So the true mean was $50,000. Thus, we have that the null hypothesis is true. If you remember, the dean rejected the null hypothesis. So since the dean rejected the null hypothesis when the null hypothesis is true, this is a type 1 error. Example 7. The dean of a business school wants to determine whether the mean of the starting salary of her graduates is $50,000. She performs a hypothesis testing. The null is that it is equal to $50,000. The alternative is that it is greater than $50,000. Suppose that the true mean is $55,000 and the dean rejects the null hypothesis. Is this a type 1 error, type 2 error, or a correct decision? We have that the true mean is $55,000. So H naught is false. The dean rejected H naught in their hypothesis test, so the dean made a correct decision because they rejected the null hypothesis when the null hypothesis was false. Example 8. Same dean, same school, same $50,000 hypothesis test. So we're going to have that the true mean in this case is $55,000 and the dean does not reject the null hypothesis. Is this a type 1 error, type 2 error, or a correct decision? We have that the true mean is $55,000, so the null hypothesis of it being equal to $50,000 is false. The dean failed to reject the null hypothesis, so the dean did not reject the null hypothesis of $50,000 when the true mean is $55,000. So the dean failed to reject the null when the dean should have rejected the null. Thus, this is a type 2 error.